Okay, so you mentioned a few different practices. Maybe list out some of those practices again and just give a brief explanation for each one. And then we'll go into depth about them after that.
Yeah, so some of the practices are like pair programming. So that is about you work in pairs and two developers work on the same computer and like same problem at the same time.
So that one sounds weird. I know that I remember learning about this practice 20 years ago, and I know there was a lot of controversy about it. Why is that one considered an important practice?
It does sound weird because when someone tells you that two people working in the same problem at the same time, which means your cost is twice as it would. But when these two people work at the same time, they collaborate a lot. And so they try to explain each other the problem or suggest a solution. With this collaboration, they are usually able to build a simpler solution. Also, the code is being reviewed constantly, so it will significantly reduce defects. And some of the study shows that when developers are working in pairs, your cost of development might go 15% up, but defects rate would go 15% down. So that will set off the cost.
Yeah. And I know that from a bottom line perspective, it's surprising, but often the overall productivity is better when you do pair programming because of the reduction in defects, the focus, and the other things you mentioned. Okay, so that's one practice, pair programming. What's another one?
Another one is test-driven development. So this is the idea that you write a test first for any feature or a product that you are building, and then develop code just enough to make those tests pass. This is important because this will force you to write your code in a way that it is testable, and you build that step by step. So you always build what is necessary for the feature. You don't build anything extra. You don't make it complex. You just strictly follow the requirements and build as much as needed. And as you're writing tests first, when you finish developing your feature, you also have a set of tests that verifies that your feature is working.
Yeah, and actually my earliest exposure to Agile was when I was a software developer. I learned about test-driven development. This is in like 1999 or 2000 or something like that. And then I applied it in my professional life, and it was absolutely incredible. It was night and day. The work that I did was so much, much better. It was simpler, as you said, way fewer defects. And I remember as a developer, I'd write a little automated unit test. And the way it works is when you write the test at first, you run it and it fails because you haven't made the code yet to make it pass. But you see this little kind of failure, and then you immediately write code to make it pass, and now you've got a success. And literally every 10 minutes, every half hour, you've got this kind of little boost of confidence because you've added another successful test. It really felt absolutely fantastic when I learned how to do this. And of course, it also made huge difference in terms of my results. And I actually got promoted very quickly because I was using this in a large enterprise environment. Not saying that you have to promote all your developers doing test-driven development, but it is amazing. It is amazing.
Could you share the reason why you got promoted?
Yeah, because no one else was writing code at the level of quality. And so like there's this funny thing that happened. I was working at Charles Schwab in California. I worked with a team. We built this system that was like this super important enterprise feature that was handling huge volume of transactions. When I was done the development phase, they passed it along to the QA group to do the testing, and I was on time. But then what happened is the QA group, they couldn't find any defects. And so they actually got really worried that they were doing something wrong, that they didn't understand what they were supposed to be testing. And so they actually blew their schedule. They were late. And in the process at Schwab at the time, they didn't have an option for if there was no defects for QA. And so it got escalated up to the VP at the time, a guy named Rich Freiberg. to get permission to not pass the work back to the developer because there was no defects. They had to get permission for that. Um, so that happened. And then the same thing happened when they tested it in the pre-production environment. Again, they had to escalate it to the VP. And at that point, the VP's like, what's going on here? Like, we've never, ever, ever had code come out of development with 0 defects in QA and 0 defects in the pre-production test environment. That led back to me, and that was the first time I got promoted. I got promoted to doing some really critical work on this enterprise system. And within, I think it was like 18 months or something like that. I don't remember the exact timing, but I got promoted to being an architect, leading a major enterprise software development at Charles Schwab. And it was really like quite amazing because it was obvious that this technique and other techniques, but that one in particular, was creating so much value for the organization. It was so incredible.
So another good practice is specification by example. In this practice, you would take a user story, and based on the user story and acceptance criteria, you would create a specific realistic examples that will be used as an acceptance test. And so you would literally put those examples in your code base and write tests again using those examples. And then you would write code to make those tests pass. So with specification by example, it will really help you to clarify all the assumptions or ambiguity about the user story that you are building, and which will lead to less rework.
Yeah, that's really important. That less rework is a big savings in a lot of complex software development environments. Now, I'd like to suggest this would be a good time to share an example. I know that you have a Miro board with a couple examples that might really help clarify this idea of specification.
So in the specification by example technique, it's basically 3 steps. So having conversations, capturing conversations, and automating conversations. So in having conversation part, it is sometimes done with the example mapping technique. So key stakeholders who have a knowledge about your product and the people who will be developing the product would have a meeting, and they will try to clarify the user story. So ideally, they would take the user story, they would put all the acceptance criteria for that story, and they would ask questions and clarify all the assumptions and create realistic examples describing that feature. And in that process, if they encounter questions that they don't have answer for, they would put in a side, and then your Scrum Master or your manager would try to get the answers for that questions before development team start building the product. And so this process would clarify the user story. So your developer will know what exactly they are trying to build. And at the end of this meeting, they would have a set of examples that they will use as a set of the tests. The second part is capturing conversations. So they use all these examples and convert them into Gherkin format, which is a simple language that uses keywords like given, when, and then to describe your examples. So the important thing about the Gherkin language is that it is understandable for everyone. So your business leaders, managers, and development team would easily understand that. So anyone could actually write those examples in a Gherkin format. And the last part is automating conversations. In this process, we take these examples that we have written in Gherkin format and convert them into acceptance test. And so we can also use like ATDD format, which is acceptance test driven development. And in that, we would write the one scenario using the one example, and then we would write the code to make that one scenario pass, and then we would refactor the code. And then we go with the second example. And so we iteratively build our software using this process.
Okay, so I understand the specification by example process in theory now. So let's look at a specific example.
So this is a specific example, how your Gherkin example would look like. So you would have a feature description here. Here I have using emails as a discount when registering for an event. And the one scenario for that is Harry Potter register for an event. So this is one specific scenario or one acceptance criteria. And then you would describe your scenario with a realistic example. So given Harry Potter uses email harrypotter@gmail.com, and certified Scrum Master event costs 1,000, and gmail.ca has a 25% discount when Harry Potter registers for a Scrum Master event, then Harry Potter's total is 750.
Let me ask a couple questions about this, actually. So, first of all, the words in green, these are similar to the keywords you were just mentioning. Is there a list of keywords or anything like that that is part of this Gherkin language that you mentioned?
Yes, so they are basically like this. So given, when, then, and end. So I have a list of keywords here. So these are the primary keyword, feature, rule. Rule is also like the acceptance criteria that you are trying to test. Example or scenario, that is the specific example for that specific acceptance criteria. And then you can describe that example using given, when, then, and but. If the example needs some preset, like user should be already logged in or they should already have their credit card in the system, then you can use something called background to provide those background in your example.
To me, this makes a lot of sense from a business perspective. How does this turn into a test or code?
So there are different tools for different programming language. One of the tool I'm aware of is Cucumber for JavaScript and Java as well, I think. I think there is another tool called SpecFlow for .NET. So you can use those tools in which you can actually write these examples and then convert that into a test. So I can show you one example in the code. So this is one example how it would look like in your code base. So you would actually create a file called .feature and write that example. And then you implement that feature with something called step file. In step file, you can implement those. And then you can, if this feature involves like a user interface, then you can use tool for UI testing such as Selenium or Cypress. Here I'm using Cypress. And so you could actually write your test, and when you run your code, it will test the end-to-end functionality for this feature.
Okay, and so very clearly then, business people write the Gherkin stuff, and then your technical folks write the code and connect everything up. Okay, good.
Yes.